All right, so we're down to the last video of chapter 4. And in this video, we're going to go over how to figure out which normal modes are bends and which normal modes are stretches. Remember that fundamentally, that's all there are. They may be given other names in other contexts, like wags or something else. But fundamentally, all you have is bends and stretches. Bends, remember, there's a change in bond angle. Stretch is a change in bond length. And so we figured out for the water molecule of C2V symmetry that we had 3 normal modes. And so the question is, which of these 3 are bends and which of the 3 are stretches? The way to figure this out is to calculate the stretches first, okay? And the way to do that is to know that, or notice that stretching vibrations change the relative positions of the atoms only along the bonds. And so that means that the symmetry of the stretches can be represented by just representation of whichever bonds are stationary. And so in order to do that, it's quite simple. You're just going to label all the bonds in the molecule and then look at the character table, and for each operation, count how many bonds stay the same, how many bonds stay stationary when you do the different symmetry operations. So identity operation, I've labeled the 2 OH bonds as A and B. The identity operation, well, that is going to take bond A and leave it at bond A, and it's going to take bond B and leave it at bond B. So I'm going to put a value of 2 there. The C2 operation, well, that's spinning the molecule 180 degrees. So bond A is going to get converted into bond B, and bond B is going to get converted into bond A. So none of the 2 bonds stayed the same, 0. Sigma VXZ, that is cutting through the molecule, right? And so again, that's going to take bond A and go to bond B, and bond B and go to bond A. So none of the bonds are stationary, so we give it a 0. Then we have YZ. YZ is in the plane of the molecule, so it doesn't do anything to the molecule, doesn't do anything to the bonds. A stays to A, B stays to B. 2 stationary bonds, we give it a value of 2. We look at how to reduce this representation, 2, 0, 0, and 2, and we get that as A1 plus B2. Where did I get that? I looked at the character table and noticed that 1 plus 1 is 2, 1 plus -1 is 0, 1 plus -1 is 0, and 1 plus 1 is 2. So if I add up A1 and B2, I get 2, 0, 0, 2, which is what our reducible representation was, 2, 0, 0, 2. So gamma stationary bond is A1 plus B2. That tells us we have 2 stretches. 2 out of the 3 normal modes are stretches. If we know which ones are stretches, we know the rest are bends, because if it's not a stretch, it's got to be a bend. So we're just going to subtract off the 2 stretches from the gamma normal modes that we have, and we're left with 1 bend of A1 symmetry. That was a symmetric bend. And so sure enough, there's a symmetric bend, 1 bend, and 2 stretches that we saw previously. All right, so that's it for chapter 4. I'll see you guys at chapter 5.